Hello everyone. Today I have come up with a problem of mechanics involving multiple concepts. So let's read through the problem once. A uniform disc shaped pulley is free to rotate about a horizontal axis passing through the center of the pulley. A light thread is tightly wrapped over it and support a mass m at the other end. A small particle of mass m naught equal to root 2 times m is stuck at the lowest point of the disk and the system is released from rest. Will the particle of mass m naught climb to the top of the pulley? Now this problem we can approach by finding out the equilibrium positions. Initially, since the torque of mg that is equal to mgr should be greater than, in fact the torque due to m naught will be 0 initially. So the system will start by rotating to the clockwise, and after some time, let us say at some position theta, the torque due to m naught g will balance the torque due to mg. So if we try to find out that position of theta, then we have to equate the torques. So torque due to mg will be mgr, and this should be equal to the torque due to m naught g, which will be equal to m naught g r sine theta. And if we use this value m naught equal to root 2 times m and solve, we get sine theta equal to 1 by root 2, which implies theta equal to pi by 4. Another value is possible here, 3 pi by 4. So at two values, the net torque will be 0. So we can argue that initially from A to B, the system will accelerate. Between B and C, the system will decelerate. So if somehow m naught is able to reach the point C, then the system will automatically be able to take C to the top. So next what we need to do is we need to apply the work energy theorem from the point A till the point C, and the final kinetic energy should be taken as greater than 0. So if the final kinetic energy of the system at the point C is positive, then definitely C will reach the top with some non-zero kinetic energy. So initial kinetic energy is 0. We are going to apply work energy theorem. Initial kinetic energy is 0. When m naught g rises till this point from from A to C, then the total height ascended by m naught will be r into r plus r cos pi by 4. So the work done in this case by gravity will be negative, and that will be equal to minus m naught g r and 1 plus cos pi by 4. The work done by gravity during the fall of mg, which will be equal to the length of the circular arc CA. This we can easily calculate by simply multiplying r with the angle rotated from A to C, which will be pi minus pi by 4. So the length fallen by mg will be L equal to r into 3 pi by 4. So the work done by gravity in this case will be positive, and it will be equal to mgr into 3 pi by 4, and that should be equal to final kinetic energy, which should be strictly positive. So we can further write that mgr into 3 pi by 4 should be greater than m naught gr and into 1 plus 1 by root 2. And if we try to solve it and find out m naught, then m naught comes out to be less than 0.975 times root 2m, which is less than the given value, which is equal to root 2 twice m. So we can argue that since m naught is equal to root 2m, and under this condition it is not fulfilling it, so definitely m naught will fail to cross the point C, and it will not reach the top. So m naught will fail to reach the top. So I hope you get it. This is a nice problem. You can go through it once. Thank you very much.